All right, so my name is John. I'm a software engineer at Red Hat. I'm just here to talk about our experience building a AI asset catalog of sorts in Backstage, and kind of what went well, what didn't, kind of how we think we can go on from there. So some background, I'm in the developer group at Red Hat, where we're currently looking at integrations with Backstage platforms and AI. One such area we've been looking at lately is the Backstage catalog and kind of how we can use that to best manage your AI assets. And this also came at a time where we started to grow our own internal set of AI resources, and we wanted a better way to manage it outside of what we were currently doing. So just, here to share our experiences. So in terms of our team's kind of internal AI inventory, we've got an OpenShift cluster for our dev and test needs, which has a set of GPU and non-GPU nodes on it. We've got an internal Backstage-based developer portal, and we've got just a set of inference servers and models that we use for our dev and test needs. And this is a mixture of LLMs, non-LLMs, but the main point is they're all exposed over an API gateway with an API gateway for each inference server, and they've each got their own set of access instructions and usage requirements, so to speak. So those last 5 will be my focus for today. For us, we didn't feel the need to model our GPUs within the catalog, just on how we were using them and how they were set up. Depending on other people's workloads and how they use them, that might warrant inclusion in the catalog. But at least for us, our focus was on those kind of last 5. So our first approach was treating models as components in the catalog. So each kind of model would be a component in the catalog of type AI model, which would depend on one or more resources pointing to its physical data files. For us, maybe it would be hosted on MinIO, maybe Hugging Face, wherever. And then each inference server we would be a system with one-to-n dependent models, like above, and an API belonging to it. And all of these resources would be grouped under that system. So that's kind of what it looks like in terms of the dependency tree. So this approach didn't work too well for us. A few issues. First up was just the redundancy of the model entities. We had both our actual deployed models in the catalog and the actual data files for the model as well represented. So there was a fair bit of duplication and just a fair bit of overhead and maintenance. AI assets that were part of a larger system were also not well represented. So if we wanted to have our AI assets belong to part of a larger system, maybe like a chatbot or something, some specific AI application, we couldn't do that because we were putting all of the models and resources under an inference server system. And then finally, it was difficult to capture the inference server specific information, whether that be usage instructions or how to log in, get first-time sign-up, stuff like that. So the second approach we took was to put inference servers as components, and this would then depend on one-to-n many models that were deployed on the inference server, and then an API resource in the catalog for its API gateway. And then to solve the issue with usage instructions and login information, we stored those under tech docs associated with the model server and model resources. And then optionally, we left the system field empty if we needed to group these together under a larger AI application or grouping of sorts later. And so this is what the dependency graph looks like for our current approach. So that's what it looks like here. We've got on the left just a basic overview of the model and model server entry in the catalog. And then on the right, we've got a view of all the models that are deployed on the model server. So when someone on our team kind of clicks into any inference server, they can easily see what models are deployed, what it's for, how to get access, etc. And then this is what our kind of usage information tech docs look like. So we've got a basic overview page with instructions on how to get a user profile on the API gateway, how to log in, how to run basic terminal commands against the API endpoint. We've got a basic open API spec for each of the API gateways, and we've configured it with each of the model server endpoints so they can log in, pass in their token, and test out each of the endpoints. So this was actually a really nice surprise when we pulled in the open API spec that this was kind of available out of the box. And then finally, we've got a very basic model card for each of the models. And for most of the models we've got deployed, I think we just ripped these straight from Hugging Face or wherever else we've pulled the model from. But something fairly straightforward that we can provide a very basic overview of the model without needing our team's developers to actually leave the portal. So in terms of what worked well, describing our AI inventory was very easy. Especially once we got a hang of the mapping of the resources to the corresponding catalog types, very easy and straightforward to do. And then tech docs easily covered the gaps in terms of what we couldn't cover out of the box with the native catalog types. And it also formed as a logical next step in terms of what the developers can find next and how to access it. And then what we're also finding is that the initial catalog extensions are proving very easy to write, especially now that we've developed this starting point for the catalog. So for us, we've been able to look into how to automatically ingest new models. And now that we've kind of got this catalog structure as the basis, we're able to, it's been very easy for us to start to write extensions along that point. And then in terms of what didn't go well, there were two kind of main roadblocks we ran into. The first was RBAC. We wanted a way to restrict access to certain models and model servers in our catalog without restricting the entire catalog. What we found was that catalog access was kind of all or nothing. Either our developers could read all of the catalog entities or they could read none at all. So we ended up just leaving it open for all and clarifying who had access to which model servers in the tech docs. And then dynamically referencing models and software templates, we wanted a way to have our models referenced in the software templates without explicitly hard coding them. Some way to fetch all of the models of some given type is what we tried to do. So for the time being, we left that part out. And so in terms of next steps, this some stuff that we're looking into, or just maybe you've got you want to develop your own model catalog and take it a step forward. Some options that anyone could do. First up is catalog extensions, like I just mentioned. Maybe you've got a backend module of sorts to pull in catalog entities that exist on the server. Maybe you've got a custom model catalog with custom views, or maybe you have software templates that reference specific model catalog entities. And lastly, you could also have a software template to import new models into the catalog. So that was all I had for today. I've included a couple additional links here if anyone's interested in learning more. Well, first up is a link to our kind of reference model catalog that we've implemented with the internal bits removed. And finally, the last one is a blog post that we've published just about our efforts. It was focusing around Red Hat Developer Hub, but as it is based on Backstage, it is relevant to a more broader Backstage as well. So yeah, thanks everyone. I'll be here staffing the various Red Hat booths this week, so if you're interested, feel free to come up to me and talk more.
Thanks, John.